Started with the problem. Okay, so let's see what's given to us. Okay. Given V initial 3.5 meters per second. That means this block was provided some force which gave it a velocity of 3.5 meters per second. So it went up the ramp. That means it has to stop at some point. Okay, and it's gonna come back down. Okay, we need to find change in x. Theta is 32 degrees. V final, that means it stops while going up, stops at some point. So that'll be 0 meters per second. So positive axis x, y, force normal, mg, m theta here, mg sine of theta, mg cosine of theta. Okay. So summation of forces, acceleration is in x direction, so mass times acceleration x. So only force acting in x direction here is negative mg sine of theta. Mass times acceleration x, right? So from here we can find acceleration in x. Putting in the values, you should get negative g sine of theta. Okay, so now we want to find how far up does it go. Okay, I'm just gonna leave it like that for now. Okay, we know because it was pushed up, this block was going up, stops, that means it's gonna come back down. Acceleration is in this direction. Okay, so v squared equals to v initial squared plus 2a delta x. Okay, this is what we are trying to find, delta x, which is v final squared minus v initial squared divided by 2a. V final is 0 while going up, negative v initial squared, 2 times negative g sine of theta. Okay, so delta x is v initial square 2g sine of theta. Now you can plug in all the values. You should get your delta x to be 1.18 meters. So B, how long does it take to get up there? So B, we use this equation, v equals to v initial plus at. So v final is 0, negative v initial is at, right? T is negative v initial divided by acceleration theta, which should give you 0.67 seconds. Similarly for C, okay, what is its speed when it gets back to the bottom? Now we want to find the speed when it gets back to the same position. So now we start from the top. So v equals to v initial plus at. So v initial, so it starts from the top with at rest, so that's 0, right? V, right? So negative acceleration is negative g sine of theta. Okay, and time is the same time. Okay, the reason is, so it started from this position, it goes up to certain distance, change in x. Acceleration is the same because your g is same, your theta is same, mass is same, your acceleration is not going to change. The displacement is the same, right? So it's like the projectile motion problem, right? So time is going to be the same, so you plug in that time. Okay, you should get this v to be negative 3.5 meters per second. But in this case, The speed while returning is negative because you are coming in a negative direction. All right, the next question here. All right. 3 connected blocks are pulled to the right on a horizontal frictionless table by a force of magnitude T3, 65 newtons. If M1 equals to 12, all the masses are given to you. Calculate the magnitude of system's acceleration. So if you want to find the system's acceleration, let's start with this problem individually, with individual mass. Okay, so the net force is equals to mass times acceleration in x direction, because it's just acting in x direction, so it's only the net force in x direction. Okay, so if you have to solve this, the main force here is T3, like that's where everything has been pulled. So T3 equals to the total mass, m1 plus m2 plus m3 times the acceleration. So if you have to look at it individually, because there will be a tension 1 acting in this string, so using Newton's third law, there's tension in both directions, T1 in both directions, because that's the magnitude of tension is same. But if you look at just mass 1, if you just look at mass 1, so we can ignore, because this is the force acting in the opposite direction. So for mass 1, we can ignore this because the magnitude is the same, only thing is the direction is different, right? So for mass 1, T1 equals to M1A. For mass 2, okay, because this has been stretched, so there's tension and mass 2 on this side, tension 2 on this side. So for when we just deal with mass 2, so tension 2 is in a positive direction, tension 1 is in a negative direction, that is M2A. So for the third one, the same thing, tension 3 minus tension 2 equals to M3A. You add them all up. So when you add them all up, so this one gets cancelled, this one gets cancelled, so T3 equals to M1 plus M2 plus M3 times A. So we need to find system's acceleration. So from here we can find system's acceleration by just plugging in the numbers. Okay, so acceleration is T3, which we know, M1 plus M2 plus M3, okay, which is 0.970 meters per second squared. Similarly for B, we need to find tension 1, which is mass 1 times acceleration. We just plug that in. Similarly for C, we need to find tension 3. Tension 2 is we can just use this equation here. So that is M2A plus tension 1. So you can, whatever the tension you find here, you can plug that in here. All right, pulleys are the devices.